Hello guys, welcome to my channel Smart Connect. This is Akrati Varun. Today we are going to learn how to build a face recognition IoT module using Python OpenCV. The basic aim behind building this project is to let's say you are not present in your house. Say like you are in your office or out of station. Now suppose you have a visitor in front of your door, and right now you cannot be present to greet him and or welcome him into your house. Now this is made possible through this IoT module. How? Simple. In this project we will have a surveillance camera or CC camera. Now when a visitor comes to your house, as he or she stands in front of your door, camera scans their face and recognizes face based on picture. You train the module and sends the data to the cloud, which sends a notification to your phone, and using the app and we will use the app to open the door so that a person can enter your house. Let's learn how to build this module. When you come to the hardware, we are using a microprocessor with a Wi-Fi module. Here the microprocessor we are using is Node MCU. Second, servo motor. Third, jumper wires. 4, B-type charging cable to give a power supply to the Node MCU. Fifth is a CC camera or web camera. For right now to build my module, I'm using my laptop camera because I don't have my webcam or the output cam. Now when we come to the software part, we are using Jupyter Notebook as to write Python codes. It's OpenCV source to write the Python code. Second thing, IBM IoT Watson platform to store data. Like the cloud here we are using is IBM cloud, and we are using the feature IoT Watson platform to build a IoT module or to extract data or to send any commands. Okay. Third thing is Arduino software. The Arduino software is a compiler which it's a C compiler which used to write the code for microprocessor or microcontrollers. Fourth one is MIT App Inventor. This MIT App Inventor is used to build the APK file apps, from which you can give the command to allow or deny. Fifth one is a Node-RED. Node-RED is another service which is provided by the IBM cloud, so that you can transfer the cloud data from one location to another location, like say from IBM cloud to your phone. Yep. Now let's start building this IoT module with Jupyter Notebook. As said, it is an OpenCV Python code software. Now just install the Jupyter Notebook from the online, the Google Chrome or Microsoft Edge. Now Now actually what we are doing here is, here we have to first build a module by training it using the different image of different classes. Here for the different classes I am using 3 images like Barack Obama and Vladimir Modi. Yeah, based on these 3 different classes I am training my module to identify the face which I to identify image or the person. You can give your visitors pictures, like suppose like you can give your house family members images, so that the module gets trained on the images and recognize them. Yeah, it's similar like your phone having a face recognition feature to unlock your phone. It's similar as this. Now I import this module from C. Like I trained my module and saved it in my module.h file. Now what I'm doing is I'm importing my module for the face recognition. Now when I compile, so what happens is, when I compile this code, the video gets captured from the webcam and the face is identified from it. It's converted to a grayscale. The frame is converted to a grayscale, and now comparison is done between the selected facial feature from the video source or the video frame that gets displayed and the image to the database which I given, or the images based on what I trained my arduino module. I'll show you it. The code here I'm showing I have in my GitHub link. I provided the GitHub link in my description. You can check in. You can go ahead and check from it. As you can see, though the number of faces generated are 1, as I'm using my webcam, it's not a high pixel camera, so it identifies my face even. It identifies my face even. So yeah. So after the match is found, it sends the data to the cloud. So here I'm using IBM Cloud to store my data. Yeah, to send the data to the cloud, first initially before creating the Python OpenCV's code, we have to create a cloud. So for this I'm using IBM Cloud. Just go to the cloud, ibm.com. Create your free IBM account. Here I'm using my existing account. Now after creating the IBM account, click on create resources. Now here you can click on the cloud end and create your cloud free cloud end data, free cloud. Yeah. Now after creating your cloud end, go to the home, go to the home dashboard, and in the catalogs type Watson IoT, yeah, Internet of Things. Yeah, click on the Internet of Things platform. Yeah, now here actually I'm having already I already have my existing light plan of free light plan of the IoT platform. So it shows me to create a new delete your existing one. So as you didn't create one, you can create a new one. Now just click on the create, and the IoT platform services will be created. To launch this app, just go to the dashboards, go to the service. Now in this service you can find Internet of Things. Just click on it. Now you will be redirected to a page of Internet of Things platform.page, and when you click on the launch button, you will be redirected to Watson IoT platform. So this helps you to get integrated. This helps you to get integrated with the IoT devices to send your sensor data or any value to your cloud. Now to create, now you have to create a device so that you can create the device type and API keys and everything. So just click on the add device. You can give your device type, or you can give your device type, or just give your device credentials or some like next. Now you can specify these details or you can skip them. Next. Now you can give your own authentication token, or you can let the event system decide your authentication token. Now when you click on the finish button, when you click on the finish button, you are all set to show this device. You will be given the device credentials, everything. Now just save them in your notepad or wordpad or any word text so that it will be used for further purposes. Now as you can see, this device is disconnected, right? So to make it connect, to turn it to the connected one, just what you have to do is, now to turn this disconnected part to the connected, we now use the Arduino software. So here's where you use the hardware part. Just download the Arduino software from any Google Chrome or Internet Explorer. Now this code is given in my GitHub link. You can go and check it. Now just give your organization ID, device type ID, and device ID, token ID, everything to this software. Now connect your node MCU, it's a microprocessor, to your PC and just upload this code. Now after the code is done uploading, click on the serial motor to check whether the Arduino software is connected to your cloud. or what's an IoT. So just press the reset button on your node MCU button. Now Redmi is my hotspot. Is my hotspot, by mobile hotspot. You can connect even to your home Wi-Fi or yeah. Yeah. Now you can see reconnected to the MQTT client a message IoT.things in IBM subscription to command OK. So now you can see the software is connected. Now the Arduino software or the node MCU is connected to your Watson IoT platform. Now when you refresh the page, you can see the status of the IoT device as connected. Yeah, see, it's turned to connected. Now in this Arduino code, whatever I mentioned here, in this Arduino code we connect so what this Arduino code does is it continuously monitors the command which is coming from the cloud. Like say, see here I mentioned a few kinds of code, like command is equals to payload, yeah, cat payload, right? This for loop, yeah. So what this for loop does is it continuously monitors from for the command to be received, which is sent by the IBM cloud. Okay. Now to send this command, now we will use another software which is also a service provided by the IBM cloud. Now just go to the IBM dashboard to create the Node-RED software. Just go to the IBM dashboard, in catalogs type Node-RED. Now just click on the create app and you will get started, and you will be asked for certain email verification IDs for passwords and remaining credentials. As I already created my services, I will just go to my dashboard, go to the service. You can find your Node-RED service in your cloud and data. So I'll click on the cloud founder service. Now I'll click on the route. You can see the status running. Now you will be redirected to the Node-RED flow. Yep. Just click on go to the Node-RED flow. Now this is your flow. These all your nodes. Now now to send the data, now even the data you're receiving in the IoT cloud or IBM cloud, you have to send this data to your application, right? Mobile application, mobile app, mobile, and then receive the command from your mobile to your Node MCU. Now the Node-RED helps you to do that using the IBM nodes, using your nodes that are mentioned in the node section. Yep, different nodes using node section. Now let's check if the data is coming first let us check if the data is received in your recent events. So for this, go to your home, go to your Jupyter notebook, compile your code, now when the code gets executed, you can see that you are getting the values like JSON values. It sends the Python code sends a JSON format value to your cloud. So you can see in recent events the updated values a few seconds ago, JSON. Yeah, now you're getting successfully, you're getting your data to you're uploading successfully the data to your cloud. Now first to send this data which is received by your cloud, just send. We have to install few libraries. We have to install one library so that your IBM node, your IBM data can be transferred to the applications. So just go to the these three dashes in the top right corner, click on the manage palette, go to the install and type node red contrib sex. Yeah, this is SEX IBM IoT app. Now as I already installed this application, you will be given, if you are not installed, you will be shown as installed. Okay, after the package installed, you can see nodes IBM input node and IBM output node. Now we have to create connection between the IBM cloud and your app and your mobile interface and your Arduino. So here what we are doing here, for this we will be requiring nodes are IoT input node, IoT output node and HTTP nodes. What this HTTP nodes does is it has three methods like get, post and put. Yeah, now this get method is used to send the data or used to create a URL. This, let's suppose like home. Okay, when you give home, it helps to create a URL which is used to send the data when the URL or the particular URL is accessed. Okay, yeah, it sends the data to the particular URL. Okay, now it's a HTTP response node which sends response back to the request received from the HTTP input node. Yeah, you can get your information about the nodes by clicking on the nodes and clicking on the information tab. Yeah, this shows everything about the node, how you can send the JSON data to the URLs or APIs. Now okay, and the nodes are function node. Now this function nodes here we are using to convert this. You can write your function definition declarations or any. The message is passed as a JavaScript object called message. Okay, you can write the messages with this function node is used to send the JSON data Okay, remaining everything you can read in your node information, or you can go to the cloud, you can go to the node.red flow, node.red flow function node, and you can go and you can read your functions. You can read about your node details in your library node.red. Yep. Now, and we will be requiring a debug. Now, this debug node is used to show all the data that is received by your by your IBM node, from your IBM nodes in your node.red flow. See, let's say you are receiving Valdemar, or you are receiving your data Valdemar or Modi or anything data will be displayed in your using this IBM debug node. Yep. Now here you will be using another node, Twilio out node. Now this node is used to send the data from your IBM cloud to your mobile application. It sends an SMS to your phone. Yeah. Now Twilio is a third-party user. Just you have to first you have to create a Twilio account. Just go to the twilio.com or console.com. Just click on sign in by using free trial, or you can pay the third-party user if you want it for the long-lasting use. Yeah, just create your free trial account. Just click on your, now just create your project. Initially, after creating your account, just create your project and click on the get number, which will give you, here I already created my project as IoT project. I gave my project name as IoT. Now this will give you a specific number, a trial number, and as account SID, account token. Save these details in your WordPad as where you saved all the Watson IoT credentials details, device credentials. Okay. Now click on the Twilio node and give all your account SSID node token and from number. Now what this Twilio third-party users does is it helps you to send receive a data from a number which the third party is providing you using the APIs. Now here we are using the HTTP nodes to receive the command which you entered or clicked on your mobile application to your Arduino software, so that you can provide the visitor in front of your door to help your visitor in front of your door to enter into your house or not. Yeah. Now just connect your IBM nodes in this format. Now in this function node, what I'm doing is that whatever the data you get in your IBM cloud, I'm converting that JSON data as a string and sending it to my Tivoli account, that is to my mobile application, and to the debug node as well, so I can see my data like Valdemar and Modi over here. Now in the to receive the command from your mobile application, I'm writing in this function node as message payload is equals message payload dot command. Now this sends this helps to receive the command from the URL, get URL, from the URL, like allow or deny command from the URL, and send it to your IBM output node, that is IBM Cloud, which further sends the data letter by letter to the Arduino software, which helps to which helps in rotating the servo motor to help the person to enter. Yep. Now click on the IoT input node, give your device API tokens and API keys and API credentials, API key and API credentials, update the server name. Yeah. Now actually it's asking for your API key and API token, right? So first you have to create your API tokens in API key so that you can transfer the data over an APIs. So go back to a Watson IoT platform. In the dashboard, select apps, generate an API. By clicking on this, it will ask for you to select the standardized API or visualizing API. Just select the standardizing API so that standard application purpose, so that you can send the data and you can use the data to other purposes. If you select the visualization API, you can only see the data, but you cannot allow the data to be used for any application purpose or what. Yeah. Now go to the IBM input node, change your API keys, input type as device event, device type and device ID from your credentials that you saved in your notepad for the IBM WhatsApp, the device you created, and done. Now go to the IBM output node, change your API keys and API tokens and service name, update, and type, give your device ID, device everything, and output type is device command. So I have to receive the command to your IBM Cloud. You have to give the command, so it helps you to receive a command from your mobile application. Now give the command type and format variables from your IBM Cloud. From your Arduino software, you can see the home and the string format to be received by your Arduino. And after selecting, giving everything, click on your Tivoli node, give a record ID from token and update, and deploy. Deployed. You can see the IBM IoT as connected, and the IBM platform also connected. Now Now you have to receive a command from your to your cloud using a mobile application. So first we have to create a mobile application. Here I'm using MIT MIT App Inventor to create my mobile application. Yeah, create your apps. Click on create apps. When the page gets loaded, now select your email account, and you will be shown all your projects that is created on your home page. Yeah. Now here for the Meta App Inventor you have two things. You have to create your front end. You have to create your back end. So to create your front end of your application, go to the designers, select all the you can see different options in your palette, user interface like buttons, labels and sliders. Click on the layouts, drag a horizontal layout. Can fill your height and width parameters. Like height for say 30. Okay. Now width, fill parent. Now you can see the horizontal parameter is filled. You can add the buttons so that you can, when you click on the buttons, now click on the user interface. You can add buttons. You can give text to the button. You can change the color of your text using your properties. Okay. After you're done with the designer block, go to the blocks. So here is where you build the back end of the application. Now just click on the buttons. Drag when button 1 is clicked, so that when you click a button, when the button 1 is clicked and the allow button is clicked, it sends a command to your cloud. Now just arrange. Now just set your backend blocks as shown. Now in the URL, now what happens is when the button was clicked, do set URL. So the web page or the page which you are using, like if you are using dot command, is set the web page, the URL is set, like just give you the URL from, copy this URL up to cloud and paste it over here. Then and enter command command is equals to allow. What this does is, when you click on the button 1, that is allow button from the designer block, when the button 1 is clicked, it sends the command allow. It sends the command allow to the URL which is specified in the node-RED /command. The similar way, when the button 2, that is the deny button, the block is clicked, the deny command is sent to your URL /command. Yep. After that, what are design blocks? Now first you have so to install this app, whatever you created in the Google, download, go to your go to your Play Store or Google Store, download, click on download MIT AI2 companion from it. Okay. Now, after you created your app, go to your app. You can see three options. Like connect with code, scan QR code. Now, click on the connect in your home page of the MIT App Inventor. Click on the AI companion or AI companion. Now, click on the button scan QR code in your mobile application. The QR code scanner gets on. Just scan the QR code on your phone. Now you can see the IoT progress bar, which shows how the app is building in your mobile phone. Yep. Now you can see two buttons, allow and deny, on your mobile phone as you build it on the designer. Yeah, you can use the build option in your home page to build an APK file. Build an APK file in your phone. Yeah, when you click on this, like same, the QR code gets open, and when you scan it, you will get an APK file download option. After downloading it, now you are all set to work on your IoT module. Yep. Now let's check if the data is when you click the deny button. When you click the button, you are able to receive the data in your Arduino software or not. So to do so, just go to your Arduino software, select the serial monitor, click on the serial monitor. Now reset your connection. Yeah, you can see the subscription. Okay, go to your Node-RED. After deploying successfully, now go take your mobile application, just click on deny. See, now when I clicked on the deny, you can see unable to identify the person, please try again. So this is displayed due to the software, due to the function which I mentioned in my Arduino code, which receives a command from the IBM cloud. Command is equals to allow or deny. When as I press my command deny on my mobile application button on my mobile application, it's checked if the command is deny or allow. As the command I press is the button I press is deny, it prints the unable to identify the person, please try again. Yeah. Now when you click on the allow, now when I clicked on the allow, the callback function here which I mentioned in the Arduino code is activated, invoked, and the person can enter command is print. Now you're all done, you're all set. You can even you're all set to start your to begin your project. Now I'll show you the full demo of how the project runs. Hello guys, now I'll show you the demo how my IoT module works. Okay, now here I got my Python code. After I start compiling it, I'll be shown a video frame, or my webcam gets activated. For if you connected the external webcams like CCC cam or anything, they will be get activated. Now I'm using Valdimo photo to recognize as a person who is standing in front of my door. Now, when I show this photo to my camera, the Python, the OpenCV code recognizes the person as a Valdemar and sends the data in the format of JSON to the IBM cloud. So here you can see in the recent events the person as Valdemar, the JSON data. Now what you can see the person a few seconds ago. The data the last received is a few seconds ago, just now. Okay, now this data through the node RED is sent to the Tivoli node, which is used, as I said before, the Tivoli node is used to send the SMS to your mobile. So by now I will get my message notification SMS as Modi, as my Valdemar is outside your house. You can see the person name as Valdemar sent by the Tivoli account. Okay, now after reading this message, I'll go to my app which I created using the MIT App Inventor, and see, this is my app I created using the MIT App Inventor. I got two buttons in it, allow and deny, as you can see. Okay, now as I press the button allow in it, the data, the command goes through the node RED to the Arduino software. Now see, right now I press the button allow on it. Now to check whether the command is received by the Arduino software, go to the Arduino software, click on the serial monitor, and just press the button allow. Just a close connection. I just recess it. I just reset it. No. Yeah. Now in the serial monitor, you can check the Arduino, the microprocessor is connected to my hotspot, mobile hotspot, and it's getting connected to my IBM cloud. So you can see the subscribe to command OK, right? So this shows that your Arduino, your microprocessor is connected to your IBM cloud. Now it continuously monitors whether the data is coming from the IBM cloud or not. As I press the button allow on it, you here on the serial monitor, I can see a callback function is invoked, and the servo motor code runs, and the motor starts rotating. As you can see, the motor starts rotating. Yeah, now the person can enter into a house, and the door automatically shuts after its time based on the delay value I give in the Arduino code. Thank you.